Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now the orthographic projections, they are also called multi-view projections because in the orthographic projections we have to draw the two or more views of an object on the reference planes which are placed at right angles to each other, and the projections which will be obtained on these reference planes, they will be 2D projections over there, and there are three reference planes which are required to obtain the views in the multi-view projections or the orthographic projections, and the names of these reference planes, they are horizontal plane, number 1, number 2 it is the vertical plane, and number 3 it is the profile plane. So these are the three planes HP, VP and profile plane which are used to obtain different projections of the objects into the orthographic projection system. Now as the name suggests, orthographic, so ortho stands for right angle projection. So in the case of orthographic projections, the rays of sight or the rays of light, they will be perpendicular to the plane of projection. That is, the projections, they will be obtained by the intersection of the rays of sight or the rays of light once they fall upon the object, and from the object they are carrying on to meet the plane of projection. It may be HP, it may be VP, or it may be the profile plane, and wherever these rays of sight, they will be intersecting with the plane of projection at an angle of 90 degree. At that positions, the projections of the object on those particular reference planes, they will be obtained. Then the imaginary rays of vision from the observer's eyes viewing the object from the infinite distance, because all these rays of sight, they will be perpendicular to the plane of projection and they will be all parallel to each other. And when this condition will be met, this condition will be met when we assume that the object is located at an infinite distance from the observer over there, right? Next, so there are three reference planes as we have discussed. So the plane of projection or a reference plane, it is a plane on which a particular view it is projected over there. So it can be the front view, it can be the top view, or it can be the side view. So in the multi-view orthographic projections, we need different planes of projections to draw different views of the objects. So as we have discussed, there are three planes which are horizontal plane, vertical plane, profile plane, which are perpendicular to each other. These planes of projections, they are called the reference plane, and the names of these planes, they are horizontal plane. So let us first of all define the horizontal plane. Horizontal plane, it is a plane which is parallel to the ground or horizon. So this is called horizontal plane, and the view which is obtained on the horizontal plane, this is called top view of the object. So on the horizontal plane, the object will be lying over here, and whatever rays of sight, they will be falling from the source of light or the observer's eyes over there. So those projection lines, they will be meeting the horizontal plane whenever the observer is going to look at the object from the top. So that is why the image or the projection which is obtained on the horizontal plane, this is called the top view of the object. Next, the vertical plane. The vertical plane, it is a plane which is perpendicular to the ground and it is intersecting with the horizontal plane. So this plane is called the vertical plane, and on the vertical plane, the image will be formed by rays of sight or rays of light when the observer is going to look at the object from the front view. So whenever the observer is going to look at the object from the front side facing the object, then the rays of sight, they will be coinciding, they will be intersecting with the vertical plane, and the image or the projection which will be obtained, this will be called front view or the elevation of the object. Then the third plane is, it is a profile plane. So profile plane, it is a plane which is perpendicular to the horizontal plane as well as the vertical plane, right? So this is a plane which is perpendicular to the horizontal plane as well as the vertical plane, and it will be intersecting with both of these HP and VP, and this plane is called profile plane. And the image which will be formed on the profile plane, this will be called left hand side view or the right hand side view. So this is called side view of the object will be obtained on the profile plane. How do we say that it is a left hand side view or the right hand side view? Whenever, let us say, object is located over here. So when the observer is looking at this object from the left hand orientation, from the left side, the image of this object which will be obtained on the right hand side, this will be called left side view of the object. So in the first angle projections, whenever you are going to look at object while it is located in quadrant number 1 from the left side, the image of the object or the projections of the object will be obtained over here on the profile plane, and this profile plane will be opened on this side. So this will be drawn on right side of the front view. Similarly, when the observer is looking at the object from the right hand side, see, observer is located over here, object is located over here. Then when the observer is looking at the object from the right hand side, the image of the object will be formed on the profile plane which is located over here, and this profile plane will be opened on this side, right? So this we will illustrate in a little while. Okay, so this projection is called right hand side projection, whereas if we are looking from the left side, so the projections which are obtained on a profile plane which is located over here, so this is called left side view of the object, right? Then let us see the projections, because we are going to name these projections as front view, top view, left hand side view or right hand side view. So let us define these projection names also. So whenever you see here we have the object, and this approach, it is called glass view approach. We are assuming that we are having a glass which is a cube, and within this glass cube our object is located. So when the observer is going to look at the object from the front, as we have discussed, so from the front when the observer is looking at the object, the projection of this object, these will be obtained on the vertical plane, and the name of this projection which is obtained on the vertical plane, this is called front view. Why do we call it a front view? Because the observer is looking at this object from the front side, right? So the first view which will be obtained for corresponding to any object in a multi-view projection or in an orthographic projection method, it is called the front view. And we must remember, front view is always obtained on the vertical plane. So let us see what is the definition of the front view. When the observer is looking at the object from the front side, then the view obtained on the vertical plane, it is called front view, or it is also called the elevation of the object, right? So front view, another name or the technical name for front view is elevation, and front view is obtained on the vertical plane. And what are the dimensions of the object which are available in the front view? You can check. This is the width of the object which is available in the front view, and this is the height of the object which will be available in the front view. So the two-dimensional object will be your front view, and the two dimensions of the front view will be the width of the object and the height of the object. Then the next view which is obtained in the orthographic projection, this is called top view. So as we have discussed, whenever the observer is going to look at this object from the top, from the upper side, then the projections which are going to be obtained on the horizontal plane, these projections will be called top view, or the technical name of the top view is plan, right? So we can say that any projections which are obtained by the observer when it is looking from the top side, so they are called top view projections, or they are called the plan projections over there. And top view is always obtained on the horizontal plane. So let us read out the definition. When the observer looks at the object from the above, then the view which is obtained on the horizontal plane, it is called top view or it is called the plan. And what are the dimensions which are available in the top view? In the top view, again, we are able to see the width of the object, and besides the width, we are also able to see the depth of the object. So width and depth are the two dimensions which will be available on the top view, which is obtained on the horizontal plane. Then the third view is side view. Now there are two types of side views you can see. This is one side view which is obtained on profile plane located on the left hand side, and there is another profile view which is obtained on a profile plane which is located on the right hand side of this glass box. So when, as I have explained you, whenever the observer is going to look at the object from the left side, so please see, in the first angle projection, it is observer, object and plane of projection. Observer, object and plane of projection. So then this profile plane will be considered. When you are looking at the object from the left side, observer will be here, object will be here, and the plane of projection will lie on the right hand side. So then since the observer is looking at this object from the left side, so the projections which are obtained on the profile plane which is located on the right hand side, then this profile plane will be opened over here like this. So these projections will be obtained on right hand side. Vice versa, when the observer is going to look at this object from the right side, then the observer will be here, object will be here, plane of projection will be located on the left hand side. That is, this profile plane will be located on the left hand side. So the projections which are obtained on the plane which is located on left hand side, but you see what is happening when the observer is looking at the object from right side, so the projections they are obtained on the profile plane which is located on the left hand side, and this profile plane will be opened like this. So when this profile plane is opened like this, so we are going to get the right side projections of this object drawn on the left hand side. So this is the idea about the side views. There are two side views which we can obtain, right? So whenever the observer is looking at the object from the side, so either from his left hand side or from the right hand side, then the views obtained, they are called left hand side view or the right hand side view. And the side view is always obtained on the profile plane, right? And the side view, which dimensions does it reveal? The side view reveals the depth of the object. Please check. It reveals the depth of the object and the height of the object. So the side view is always going to obtain the depth and the height, whether it is a left side view or it is a right hand side view. And for the longer objects of the uniform cross section, let us say you have a long pipe or a spline, then we may call side view as an end view, because whatever is the dimension at the end, so same dimension will be available onto the side view if it is a uniform pipe. So for a uniform pipe, or let us say we talk about a tube light also. So whenever you have a uniform tube light, the end view will be what? It will be a cross section which is a circular cross section. So there are no change in geometry, but for the normal component you can see there will be change in cross sections over there. So you cannot call this an end view. Only for the uniform objects having longer lengths, the side view can be called as end view. Then the next thing is orthographic projections. We can see other than these three projections, there are two more projections which can be drawn. You can see one is the bottom view and another one is the back view. So whenever you are looking from the bottom, because the cube is going to have 6 faces, so the 6 views we can get. So one view we have discussed front view, another view we have discussed top. Regarding side, we had 2 side views over there, so we are left with 2 faces of the cube over there. So for corresponding to these 2 faces of the glass box, so 2 more views are available. So whenever you are going to look at the object from the bottom, so whatever view will be obtained onto this top surface, please check, this is our top surface. So this surface will carry a view which is called a bottom view. So let us read out the definition of the bottom view. Whenever the observer is looking at the object from the below, then the view obtained, it is called bottom view or the bottom plan. And just like the top view, the bottom view will also be showing us the width and the depth. You can check, the top view was also showing us the depth and the width. Similarly, the bottom view will also be showing us the width as well as the depth of the component. And the last view is rear view. So rear view means you are looking from the back side. Back side means the rear side. So whenever you are looking at the object from the rear side, whatever view will be obtained on this surface, on this plane, this will be called a rear view or a back view, because you are looking from the back side. So the rear view, just like the front view, it will also be showing us the width and the height. Similarly, the rear view or the back view will also be showing us the width and the height of the object. But we are seldom drawing the bottom view or the back view over there. Usually we are required to draw the front view, the top view, either of left side view or the right side view. So we may be required to draw both the side views, but in most of the occasions we are required to draw three views of the object, which will be front view, top view, and either of left side view or the right side view of the object. Now you can check, these are the glass box, and within the glass box these are 6 views. So there are 6 views which are obtained in the glass box. Now in the front view you get this projection, and in the first angle projection the bottom view will be drawn above the front view and the top view will be drawn below the front view. Similarly, the left side view, as I told you, will be drawn on the right hand side, and right hand side view of this object will be drawn on the left hand side of the front view. So back view will be drawn next to the left hand side view over there. So this is how all the 6 views, they can be represented in a single 2D plane, because otherwise you check, these 6 views, they have been obtained on mutually perpendicular planes over there. So we have to carry out the rotation of these 6 faces of this cube so that we can obtain these 6 views onto a single 2D sheet or even our computer screen over there. So usually we have to draw all these views onto the drawing sheet, onto the computer screen. Then we have to rotate all these faces in the designated direction. So the front view will be rotated in the clockwise direction. The profile plane, it will be inclined in this direction. If you have your profile plane which is oriented toward the right, then it will be folded in this orientation. Similarly, if you have the profile plane which is oriented towards left, then this will be folded in this direction. It will open out in this direction. Similarly, the bottom view, it will be opening in the upward direction. That is why you can check, bottom view is appearing above the front view. So this way, even the top view is there. This is the top view. So top view, it is drawn on the horizontal plane. So horizontal plane, as I told you, this will be drawn below the front view, because horizontal plane will be rotated in the clockwise direction. So these rotations, I will be explaining it to you in a little bit more detail in a little while. Now, in the orthographic projections, there are 3 types of lines which will be used. The first type of lines, they will be visible lines. So the visible lines, they are going to be representing the outlines of the object. So this is the visible edge. So any outline of the object, you can see this is the outline of the object, this is the outline of the object, this is again the outline of the object, this is again the outline of the object, or wherever the cross-sectional changes they are occurring. So all those edges of the solids, they will be represented by the visible lines or the outlines over there. Where are the hidden lines? The hidden lines will be showing us those portions of the solids which are not visible. Let us say if I have to look at this solid from this orientation. So there is a hole over here, but this hole is not visible from this side. So there you can check, a dotted line I can draw over here. This is a dotted line. So this is the dotted line or a hidden line which I can draw. Then the third type of line is center line, because this is a symmetrical object. This is a cylinder within this square prism. So square prism is also symmetrical. cylinder also needs to have an axis over there. So axis will be represented by big, small, big, small, big, small chain line over there. So these are the three lines which will be drawn in the orthographic projection. And another benefit of using the orthographic projections compared to the isometric projection, it is that in the isometric projections we cannot view the hidden lines over there. No hidden lines they are drawn, right? So for this solid, even for this square prism, we have not shown the edge which was lying over here. So we did not complete the back portion of this particular square, that is the back side of this square prism we have not drawn. Similarly, if there is a hole over here, I do not know from this drawing whether this hole is running through and through the object, or this hole is running quarter length of the object, or this hole is running half length of the object, or this hole is running 3/4 length of the object. So from this drawing it is not clear. But if I draw the orthographic projection, then the dotted lines drawn over here, they will clearly represent the length of this particular hole within this particular solid, right? So this way the isometric views, they are having the limitation that the hidden lines, since they are not drawn, so we cannot have the appropriate idea about the construction or the geometric features of those components. So here is another example over here. So here you can see we have a rectangular prism over here. Please see, this is a rectangular prism which is having a hole within. So this hole is having a size 20 millimeter by 60. And if I just write 20 by 60, does it give me any idea what is the depth of this hole? No. If I write down through over here, it means this hole will be running through. So in the orthographic projections, since I am going to show the hidden lines corresponding to the interior details of the objects, so this is a hollow object. So this portion, this wall, this wall, this wall and this wall, they have been shown as dotted line. And since this is running through and through, so without giving any note, I will be sure that what is going to be the depth of this hole. But in the isometric projection, I need to give a note over here. Otherwise, looking at this drawing, it does not make it clear that what is going to be the depth of this hole. I have another example. Please check. Drawing is just similar. There is no difference in these two drawings. Please check. There is no difference. But then here I have given a note that the hole dimensions, they remain the same, 20 millimeter by 60 millimeter. But this hole is running 50% depth of this particular component. That is, if this depth is or the height is 60, then it is going up to 30 millimeter. But the drawing is not showing you that particular depth of this hole. So in the orthographic projection, since I am going to show the hidden lines over there, so more accuracy, no special notes will be required in this particular case. So this way, orthographic projection, they give you the better visualization. Another thing, in the isometric projections, the front view, the side view and the top view, they are all inclined at an angle of 120 degree each. So all the three faces of the solid, they happen to be inclined to the plane of projection. And because of this inclination to the plane of projection, I am going to get reduction in the sizes of the dimensions over there. So the shapes, they are not going to be preserved in the isometric projections. The angles, they are not going to be preserved in the isometric projection. That is another limitation of the isometric projection. But the benefit of isometric projections is that they give you the feel of the object. Just see, if I give these three drawings, front view, top view and left hand side view, to any observer and ask him, okay, I am having a rectangular prism which is going to have a hole over there. A layman will not be able to develop or combine these three views into a single view. So for a layman, this view is good, but for the manufacturing, orthographic projections, they provide you the better details and of the object over there. Now these are the first angle projections. Please check. Here we have the object. Here the observer is there. Here my plane of projection will be there. And as we have discussed, on the vertical plane, we are going to get the projections, and the name of the projections will be front view. And why do we say this is front? Because observer is looking at this object from the front side. So these are the front views. And dimensions, which dimensions they are available in the front view? Width and height of the object. Now next, when the observer is looking at this object from the top, then once again the rays of sight or the projection lines, they will be perpendicular to the plane of projection. Even in the front view, the rays of sight, they were perpendicular to the plane of projection and they were parallel to each other. Whenever the observer is going to look from the top, so on the horizontal plane, whatever projections will be obtained, the name of those projections, they will be called plan or top view projection. And in the top view, we have got the width and the depth of the object. Next, whenever the observer is going to look at this object from the left hand side, so once again the projection lines, they will be perpendicular to the plane of projection, and the name of this plane of projection will be profile plane, and the projection name, it will be side view. And since the observer is going to look from the left hand side, so they are obtained on the right hand side, and this profile plane will be opening on this side. This horizontal plane, it will be opening downwards, that is in the clockwise direction. So in a single plane, all these three projections, they can be obtained. So this horizontal plane will be rotated downwards, that is clockwise. Profile plane, it will be opening up this way, because this is going to be my hinge for the profile plane. This is going to be my hinge for the horizontal plane. So horizontal plane will be moving downwards with respect to this hinge. The profile plane will be opening towards right with respect to this hinge over there. So front view will be obtained above the XY line, top view will be obtained below the XY line, just below the front view, and side view will be drawn next to the front view on the right hand side. So left side view will be drawn on the right hand side. So please check, this is front view, this is top view, and this is left side view. And similarly, if the observer is going to look at this object from the right side, then the profile plane will be located on this side and it will be opening over here. So then you are going to get right side view on the drawn on the left hand side of the front view. So this is how all these four views, they can be located in a single two-dimensional plane over there. So this is another representation. So please check, this is horizontal plane, this is vertical plane, and this is profile plane. So this is profile plane located on the right hand side. Similarly, we are going to get another profile plane which will be located on the left hand side over there. So when the observer is going to look from the front view will be obtained here. When the observer is going to look from top, the top view will be obtained on the horizontal plane. When the observer is looking from left side, the view will be obtained on profile plane which is located on the right hand side. And horizontal plane, it will be moving downwards, right? The profile plane which is located on the right hand side, it will be opening in the right hand side direction. Why? Because this is my hinge over here. For this right hand side profile plane, this will be my hinge. For my horizontal plane, this will be my hinge. So vertical plane will stay as it is. Horizontal plane will be moving downwards. Right side profile plane will be moving towards right side because of this hinge. And we have another hinge for the left side profile plane, right? So for the left side profile plane, please check, this is another profile plane which is obtained on the left hand side. And here we have this hinge. So since hinge is available over here, so when the observer is going to look at the object from the right side, image will be obtained over here, or the projections will be obtained over here onto left side profile plane. And then since we have hinge over here, then in this particular profile plane will be opening towards the left hand side. So this is the original position. Now let us see how the openings, they are occurring over here. HP has moved down, VP is moving, right side profile plane is moving toward the right side, and the left side profile plane, it is moving towards the left side. So this is moving towards left, this is moving towards right, and horizontal plane is moving towards downward direction or the clockwise direction. This is the clockwise direction. Then in the third orientation, please check. Front view is drawn above the XY line. Top view, it is drawn on the horizontal plane below the XY line. Left side view is drawn on the right hand side, and right side view, it is drawn on the left hand side. Right? So this is how all your 4 projections, they can be obtained onto the orthographic projection. So this is how we are going to obtain the projections on the orthographic plane. So this is also profile plane, this is also profile plane, right? So whenever we talk about the left side view, it will be drawn on the right hand side. Whenever we talk about right side view, it will be drawn on the left hand side of the front view over there. So this is the front view, then you have the top view, then next you have the left side view on the right side, and then you have the right side view on the left hand side. So this is the illustration of how the different planes, they are going to be rotated in such a way that the multiple views, they can be obtained on a single 2D plane or a drawing sheet over there, right? So let us see how these projections, they can be made. Now here we have, this is an object, this is the observer location. Whenever the observer is looking from the front side, you see the projections, they are perpendicular to the plane of projection, which is a vertical plane. So on the vertical plane, this is the projection or the image which will be obtained. This is the face 1 of the object which will be visible from the front side. This is the second face. Please check, this is the second face of the object which is observed over here. So this is my front view of the solid. Then when the observer is going to look at the top, now if you are looking from the top, which plane will be used over here? Horizontal plane. So if the observer is going to look at the object from the top, the projections which are obtained on the horizontal plane, they are called top view projection. So in the top view, please check, I will be able to see this face of the solid, face number 1. Then the second face which will be visible from the top, this will be face number 2, and this is my face number 3 which is visible from the top. So this is my top view which is obtained on the horizontal plane. Then the left side view, when the observer is going to look at this object from the left side, please see, observer will be able to see these projections, 1, second face, and the third face over here. These 3 faces will be observed from the side view, and this side view is drawn on the right hand side. So observer looking from left side, view is obtained on the right hand side. So in all these 3 views, we can check that the projection lines, they happen to be perpendicular to the plane of projection, and they are all parallel to each other, whether you talk about side view, whether you talk about the top view, or whether you talk about the front view which is being obtained, right? So front view is obtained on the vertical plane, top view onto the horizontal plane, and side view will be obtained on the profile plane. Now once we rotate, this will be rotated towards right, this will be rotated downwards. So all these 3 views, please check, they have been obtained on a single 2D plane over there. So this is front view, this is top view of the solid, and this is side view of the solid, right? So all these 3 views, they have been obtained on a single 2D plane. Now similar examples are there. This is another object, and we can see the rays of sight, they will be perpendicular to the plane of projection. So when you have to draw the front view, this will be drawn on the vertical plane. So rays of sight, they are parallel to each other and perpendicular to VP. Similarly, whenever you have to draw the side view, the rays of sight, they are parallel to each other and perpendicular to the profile plane. Similarly, when you draw the top view, the rays of the side, they will be perpendicular to the HP, and you will be able to get the front view, the top view, and the side view of the object. Then HP will be rotated downwards, profile plane will be rotated on the right hand side, VP will stay in its position. So these are the projections which will be available. Front view above the horizontal plane or the XY line, top view, once you rotate this, HP, this is the hinge over here, and this will be rotated downward. So front view will appear above the XY line, top view which is obtained on HP, it will be appearing below the XY reference line, and your left side view is appearing on the right hand side over there, right? So few more examples we have shown. This is another object. This is front view obtained on VP. This is top view which is obtained on the horizontal plane, and this is side view which is obtained on the profile plane. So please see, all these projections, they have been drawn by rotation of all these planes of projection in the appropriate directions over there, right? So another example is this one. This is the object. So front view, left side view on the right hand side, right side view on the left hand side, and this is the top view. Now please see the difference between left side view and the right side view of this solid. Whenever the observer is going to look at this particular solid from the left side, so this face the observer will be able to see, this face the observer will be able to see. So two rectangles, they are available on the left hand side view which is drawn on the right hand side. But when the observer is going to look at the solid from the right hand side, please check, only one face which is lying on the rear side will be visible to the observer. So one big rectangle is visible, but this change in cross section is not visible to the observer. So when the observer is looking from this side, so this flat edge of the surface, it is not viewed by the observer. So this edge, it has been drawn by the dotted line. So that is why we insist on drawing multiple views, so that if we are not able to see few edges from one orientation, we will be able to see those edges from some another orientation. So in the right side view, this edge or the surface is not visible, so it has been drawn dotted. But the moment we draw the left side view, so automatically this edge is now visible, this surface is now visible. So this has been drawn by using the object line or the darker line. So this is the significance of using multiple views over there. So few edges, they might not be visible from a particular orientation. They have been drawn from other orientations, and you are able to get the better visualization of those surfaces over there, right? Now, few more examples we have picked up. Let us say this is an object. This is my front view. If this is my front view, please check. Front view will be drawn above the XY line. So this is my lower ring. This is my lower surface or the lower block of the object. And if I draw the projections of this object while I am looking from this side, this is my front view orientation. So I will see that this is, please check, one L-shaped object I will be able to view over here. This is my L-shaped object which is visible to the observer while I am looking at this object from this orientation. But this surface is not visible. So since this surface is not visible, the dotted line will be drawn over here. This hole is not visible from this side. So the dotted lines, they have been drawn corresponding to the location of the hole. So please check, this is also dotted because this surface is not visible. Now let us view this object from the top. So from the top, please check, let us see how I can view. So please check, this is a slanting position over here, slanting surface. So one rectangle will be there corresponding to this web, one rectangle over here corresponding to this web. But these smaller rectangles, they are also drawn to take care of these slant surfaces. So this edge will be drawn, this edge will be also drawn, this edge and this edge will be drawn, and the slant will give me this position over here. So this is apparent shape of this slant surface. This is also apparent shape of the slant surface. This is true shape. This is true shape. And now the hole I will also be able to see over here. So I'll be able to see the hole over here, right? So hole is visible in the top view which was not visible in the front view. Let us draw the side view. Now in the side view, I will be getting one rectangle over here corresponding to the bottom. This rectangle is there corresponding to the bottom block. Then this trapezoid structure will be there. This trapezoid structure will be there, and this is a hollow portion which I can see from the side view. So since this is a right side view, please check, this right side view has been drawn on the left hand side of the front view. So this is the construction of the multi-view orthographic projections over there. And again, we cannot see this hole from this side as well. So that is why the dotted lines have been shown in this particular block over there. In this rectangular block, this hole was not visible, so we have drawn the dotted lines over here. Then similarly, you can see few more examples. If we are looking at this object from the front, so this is the view we will be getting, that is surface A. This will be visible. If I am looking from the top, then surface B, C and D will be visible. So three rectangles will be visible. One rectangle corresponding to surface B, another rectangle corresponding to surface C, another rectangle corresponding to surface D. Then if I am looking from this side, then I'll be able to see surface 1 which is vertical, surface 2 which is vertical and surface 3 which is visible. So the three vertical surfaces 1, 2 and 3, they will be visible over there. And once, please see, vertical plane will stay in its position, horizontal plane will be moving down and this plane will be moving towards this direction. So right side view, I am looking from the right side, it will be drawn on the left hand side. So this is my front view. So front view I have reproduced over here. Which surface it is going to show me? Surface A, right? So in the top view, which surfaces will be visible? Surface B, surface C and surface D. So these are the three surfaces which will be visible to me. And from the side view, right side view which has been drawn on the left hand side, so these are the three surfaces which are visible: surface 1, surface 2 and surface 3 over there. Similar example is there. You have front view drawn on the vertical plane, top view drawn onto the horizontal plane, and now the left side view which has been drawn on the right side profile plane. So this is the left side view which has been drawn on the right side profile plane. So this will be opening towards right hand side. So left side view will be drawn on the right hand side. Now similarly, we have drawn multiple projections in the first angle projections. Similarly, we can draw projections in the third angle projection system as well. So in the third angle projection, we will assume that the object is located below the horizontal plane and behind the vertical plane. So this is my horizontal plane and here is my vertical plane over there. So in the third angle projection, what is the sequence? My observer is located here, plane of projection is intermediate, and then the object will be located. Similarly, from the top, observer will be located here, plane of projection will be intermediate, and then my object will be located. So in the third angle projection, front view is drawn below the XY line, top view is drawn above the XY reference line, because you see, on the vertical plane, front view will stay in its own position, whereas this horizontal plane, as I told you, that this will be rotated clockwise. So this will be moving upward. So your top view will be drawn above the XY reference line, right? So this is the front view. And the profile plane, now you see, I am having two profile planes, one on the left side, another one on the right hand side. Now once I am going to look at this object, while my profile plane is located on the left side, the image will be formed on the profile plane which is lying in the intermediate position, because now my sequence is object, this is object, then the plane of projection, and then the observer. So the projections will be obtained in the intermediate plane of projection. Now once I am looking from left side, I am going to obtain the profile plane projections on the left side only, not on the right side. Now the projection, they have been obtained on the profile plane which is located on the left hand side. So this will be opened on the left hand side. So the left side view will be drawn on the left side in the third angle projection. Similarly, if I draw the projection from the right hand side, my profile plane will be located on the right side over there. Then this right side projection will be opening, profile plane will be opening on the right side. So the right side view will be drawn on the right hand side of the front view, which will be again drawn below the XY reference line. So this is the difference between first angle projections and the third angle projections over there. So this is the procedure, and let us see few examples of third angle also. So HP will be rotated clockwise. It is lying behind. So this will be rotated clockwise. Here, this is going to be my top view over here, right? So that is how I am going to obtain these projections. Now again, I am going to use the glass box approach in order to draw multi-view projections in the third angle projection. So let us see how do we proceed. This is my object which is located in the third quadrant. So in the third quadrant, this is my front view. This is my intermediate plane over there, which happens to be the vertical plane. This is my observer. This is my horizontal plane, and onto this horizontal plane, the projections will be obtained. Similarly, this is my observer. This is my profile plane, and this is my object. So everywhere, observer, plane and object, observer, plane and object, observer, plane and object will be there. So all these projections, they will be obtained on the intermediate plane in the third angle projection. So let us draw the front view. So please check, when the observer is going to look at the object from the front, the projections obtained on the vertical plane, they are called front view projection. Now let us look at the top view. When the observer is looking from the top, so on the horizontal plane, the projections that are obtained, they will be called top view or the plan, and this horizontal plane will be moving upward. This will stay in its position. And now let us look from the right hand side. Now this is the intermediate profile plane located on the right hand side. So projection, they are obtained on right hand side. So this will be opening towards right. So front view will be drawn below XY. Right side view will be drawn on the right hand side below XY, and the top view will be drawn above the front view projections, which will be drawn above the XY reference line. So these are the projection: front view, top view, and the right side view. So right side view projections, they have been drawn on the right hand side. So this will be moving upwards over there, right? So this is how the projections, they are obtained. Front view, this is my top view, this is my side. So please say, this is front view drawn over here, this is my top view drawn over here, this is my side view, right side view drawn on the right hand side. So both the side views, they will be drawn below the XY reference line in the third angle projections over there. Now let us see the comparison between third angle and first angle. So this is the symbol for third angle. So in the third angle, this is my front view. So the front view, I cannot see these holes over there. So this bolt has to be fitted in this square block. So please see, this bolt I cannot see from this side. There is a slot where the bolt head and the bolt shank can be accommodated. So this cannot be seen from this side. So this has been drawn dotted. So this is my front view. Then the top view, as I am looking from the top, I will be getting a square and one circle and another circle over here. And this hole is not visible from the top. So there will be dotted line corresponding to this hole over there. So dotted line corresponding to this hole. Then the side view, now this is my right side view, will be drawn on the right hand side over here. Right side view will be drawn next to front view below the XY line. Let me draw this. Now I can see this hole. Please see, I can see this hole, but again I cannot see this bigger hole where the bolt head and the bolt shank had to be accommodated. So this is the construction in the third angle projection for this component. So this is the symbol of the third angle projection. Now next one, I will be drawing the first angle projections for the same component. So this is my front view. Front view will be drawn above the XY line over here. So height and the width will be shown. So once again, I cannot see this interior hole for the bolt and the shank. So this is not visible. Similarly, from the front view, this is also not visible across this length. So this has been drawn dotted over here. Similarly, over here. In the top view, I will be getting a square and one hole over here visible, another hole for the shank again visible, and this hole is not visible. So this will be drawn dotted over here. Next one from the side. So side view, I am looking from the right side. I am looking from the left hand side. Please check. I am looking from the left hand side because I am required to draw the left hand side view. So since I am looking from the left hand side view, so this view is similar to the other view, even though it's not visible, right? So in the left side view, this hole will be visible. This particular bolt section and the shank section, they are not visible. So square I can see, this bolt head and the shank section I cannot see, but this circular hole I can see from the other side. So this is my projection in the first angle projection, right? So this is the comparison of first angle and third angle projection. So this is another comparison of first angle and third angle projection for a component using the glass box technique over here. So in the third angle, front view is drawn below XY, top view is drawn above XY, and right side view is drawn on right hand side of the front view, whereas in the first angle, front view is drawn above XY, top view is drawn below the XY, and right hand side view, you are looking from this side, it is drawn on the left hand side of the front view. So here the side views will be drawn above the XY line. Here the side views, they will be drawn below the XY line. Here in third angle, right side view will be drawn on right side, left side view will be drawn on left side, where a reverse will be there in the first angle. In the first angle, right side view will be projected on the left side and left side view will be projected on the right side of the front view. So this is the comparison of multi-view projections, that is orthographic projections using first angle and third angle projection. So this is all about the introduction to the orthographic projections. So we will be continuing with more practical problems related to the orthographic projections in the coming lectures. So this is all for today. Thank you very much. Thanks.